Okay, so question number 10 of applications to trigonometry says a triangular playground has borders around has borders of 52 feet, 70 feet, 64 feet, and 64 feet. To the nearest degree, what is the measure of the largest interior angle of the triangular prism? What is the area of the playground? And what is the area of the playground? Okay? So it's asking us to figure out the area of the playground, the area of the largest interior degree. So first, not the area, but the measure of the largest interior angle. So let's just write the triangle out first so we can have an idea of what we're doing. So it has a 52 feet side, a 70 feet side, and a 64 feet side. Well, I know that that the largest side will always have the largest angle because it just has to it has more space to project a larger image, right? For the triangle. So the largest side will have the largest angle. So that means that 57 is the side that we're going to use to find the missing angle. And I know that this is law of cosine, right? A law of cosine says a squared plus b squared minus 2 ab cosine theta equals c squared, right? I know that. But another way you can do this is a formula derived from this exact expression, which says that a squared plus b squared minus c squared divided by 2ab equals cosine theta. And you can derive this by moving it's a whole lot of math, but you're basically moving these integers over to c squared, and then it will be negative, so then you do the inverse. There'll be two negatives, so it'll just be positive, and so that's how the c squared becomes negative. It's a lot of math, okay? But yeah, that is basically a formula derived from that exact same formula, and it can help you find a specific angle you're looking for. And so the specific angle I'm looking for is 70. So since 70 is my angle I'm looking for, I'm going to put it at C. So now I'll just substitute. So 52 squared plus 64 squared minus 70 squared divided by 2 times 52 times 64 equals cosine theta. Now, I'm going to find the value of the numerator and the value of the denominator and then divide them to get the value of cosine theta. So 64 squared plus 70 squared minus 52. My bad. 52 squared plus 64 squared minus 70 squared divided by 52 times 64 equals negative 3 point. Okay, so it equals negative 3 point. Negative 0.320312. So negative 0.32 0 3 1 0 3 1 2 5 1 2 5. That equals cosine theta. Now we have to multiply by cosine inverse, so I can isolate the theta and find out what the angle measure is. So multiply by cosine inverse. Cosine inverse. And we would find out that the measure of angle of the missing angle, or the largest interior angle, is 108.68. So theta equals 108.68. But wait, the question asks for the large interior angle to the nearest degree. So we have to round this up to the nearest degree because it's over, the decimal point is over 0.5. So that means that theta equals 109. So that means that the largest interior angle of the triangle playground is 109. Right? That's good. Now that we know this, we have to find area. So let's find out area. So there are many ways to find area. You could do half AB sine C, or angle C, sine of angle C. You could do that, right? Or you can do Heron's formula. And I'm gonna prefer to use Heron's formula because it's less arbitrary than this one, where you'd have to just pick what side you choose and then you have to change your formula. But Heron's formula is just square root of s minus a times s minus a times s minus b times s minus c. It's just less arbitrary, and it's easier for you, and I feel like it's easier to do. And s equals a plus b plus c divided by 2. So yeah, that is why I'm going to use Heron's formula. But you could use you could also use this formula above, right? You could use this one, but this one is a little bit more arbitrary, and your answer will not be the exact number because we rounded up our degree, right? Our degree for here, we rounded it up, so it won't be the exact number. But Heron's formula, we'll always get the exact number because it's just using side lengths, and we know all 7 sides. I mean, all 3 sides. We already know all 3 sides, so it'll just be, it feels easier to use Heron's formula. So let's find out what s is. So 52 plus 70 plus 64. We can just choose any numbers in any order. It's just that we know all the sides, so we don't need to necessarily do that. Divided by 2. We just have to make sure we can put any numbers as A, B, and C in this formula, in Heron's formula, because we know all the sides. So this would equal this would equal 93. Yeah, 93. Okay. So now that we know what S is in Heron's formula, we'll now do this. So 93 times 93 minus 52 times 93 minus 70 times 93 minus 64. And once we solve that, we can input into a calculator, the answer would be, our area would be 1,594.7636 19. So the area of this triangle would be 1,594.763619 feet. So our area is 1,594.763619, and the large interior angle will be 109 degrees.